Hello, test. This is a simple test to verify if my audio is okay. Hmm. Today it's the second day. Um, I try to learn Elixir. Now I will start to do this is exercise in IO and file system. Let me see here. Mm, okay. IX clear. This chapter is an introduction to input and output mechanism, file and system related tasks in related modules such I/O, file, and path. This I/O system provides a great opportunity to shed some light on some philosophies and curiosity on Elixir and VM. The I/O model. The I/O model is a mechanism in Elixir for reading and writing the standard input-output STDIO, STD standard error file, and other I/O devices. Use of the model is pretty straightforward. Let's try IO dot puts hello Elixir. Simple. IO gets. Are you ready? Yes. Simple. We have a new line here for default. By default, functions in the I/O model read from the standard input and write to the standard output. We can change that by passing, for example, a column std err is argument in order to write to the standard error device. Let me try. IO puts std to the okay, simple. The file model. The file model contains functions that allows open write as IO device. By default, files are open in binary mode, which requires developer to use the specifying IO.beingRead and IO.beingWrite functions from the IO module. Clear. Okay. This here is instructions. I think like JS instruction. This function will open a file or new file and the return of. Let me see. Open file dot open. Okay. Here here, press. Okay, very simple. Okay. Well, equal file open path a new file. New file txt mode. Oops. Okay. This is interesting because I think it opens a new threads, a new spawn, because we get a new PID here. If I type self, you get the current PID for this process. You can see, and no, this is the same. It's the same for now. No, it's the same. The PID is the same. I was thinking it's create a new PID. I'm wrong. Okay. IO dot write file. This is first. Okay. I think this we write this line for this text, create a new file and put this content inside it with it. Okay. File. Close file. File. Read. New file. Okay. So good. That's nice. It's read the file and read the. I don't know if I open again. It's let me try because I want to know if it open a new line or overwrite the current line. Here, okay, again. Should be second line. Okay, close file. Read. New. It overrides the current. I think we need to. Um, I think is there some option you put here? They don't overwrite the current line, but okay, it's okay. It's a file can also open with a UTF-8 encoding, which tells the file model to interpret the bytes read from the a file as file is that encode bytes. Let's try. No, it doesn't work. No problem. I will try it. Okay. Basic function for open, read, and write files. The file models has many functions to work with the file systems. Choose functions are named after the Unix equivalents. For example, file.rm can be used to remove files, file mcard dir to create directories, and so on. Right. That's so good. You will notice that functions in the file model have two variants. One regular variant and another variant with the trailing bang. For example, when we read the reload file in the example above, we use file.read. Alternative, we can use file read bang. Notice the version with the bang returns the count of the file instead of a tuple. If anything goes wrong, the function writes an error. The version without bang is preferred when you want to handle different outcome using parameter, case file. Case file to read file, do, okay, party. Is file dot read the path you file dot I don't know if this will work. Mm, no, doesn't work. Variable set. Path model. The majority of the function in the file model expect path is arguments. Most common, this path will be a regular binaries. The path models provide facilities for work with such paths. Path join, O bar. Path expand, If this is okay. Path. Use the function from the path model is opposite to direct manipulation string is preferred since the path model takes care of different operation system it transparently. Finally, keep in mind that elixirs will automatically convert slashes into backslashes on the Windows when performs final operation. With this, we have covered the main models that Elixir provides for deadline with I/O interacts with the file system. In the next section, we'll pick a bit under the cover and learn how the I/O system is implemented in the VM. I think virtual machine. Process. Okay, I know what process. Yes. If you have noticed that file open, return a tuple. This is a tuple. Okay, tuple. Tuple. Okay, return a tuple. This happens because I/O models actually works with process. See chapter 11. Give a file. Given a file is a process. Given a file is a process. When you write to a file that has been closed, you are actually sent a message to a process which has been terminated. This is important. Given a file is a process. When you write to a file has been closed, when you write to a file that has been closed, okay, you are actually send a message to a process which has been terminated. File.close file. Oh, there. Let's see in more detail what happened when you try IO.write PID binary. The IO module sends a message to the process notified by PID with the desired operation. A small ad hoc process team helping us see it. Just create a new PID, a new process here. This is my current process. I have two processes here, right? And I use okay. The process is dead. The process is dead. The process is dead. After io.read, we can see the request sent by IO model printed out a 4-element tuple. 4-element. Okay, 4. So after that, we see that its file, since the IO model expects some kind of result. We did not supply. We did not supply. Okay. By modeling your device with process, the Erlang VM allows IO messages to be routed between different nodes run distributed Erlang, or even exchange file to perform the read and write operations across nodes. Yet IO data. Oops. Okay. Here IO data and chart data. In all of the example above, we use binary when write to files. However, most of the IO functions in Elixir also accept either IO data or char data. One of the main reasons for using IO data and char data is for performance. For example, imagine you needed to greet someone in your application. name Mary. I will put hello Mary. Okay. Given string leaks are immutable. Given string leaks are immutable. Is most data structure, the example above will copy the string Mary in the new hello Mary string. While this is unlikely to merge for the short string it's above, what can be quick expensive for large strings. What's reasons the IO functions in Elixir allow you to pass instead a list of strings. The example above, there is no copying. Instead, we create a list that contains the original name, and we can set list either IO data or shard data, and we learn the precise difference between them. Some those lists are very useful because it can actually simplify the process strings in several scenarios. For example, imagine you have a list of values such as apple, banana, lemon, uh, that you want to write to this separated by comma. How can you achieve this? One option is to use enum.join and convert the values to a string. Okay, join. The above returns a new string by copying its value in the new string. However, with the knowledge in these sections, we know that we can pass a list of string to the IO slash file function. So instead we can do IO data and shard data do not only contain string, but they may contain arbitrary nested list of string too. alias required import. Okay, this is I will see. For now, it's enough. It's enough.